State that transition elements can form more than one ion. Well, I am at the mall right now. Isn't freedom great? Wow, there's a periodic table right here. You have the metal on the left side, transition metal, and the non-metal on the right side. But in this topic, we're just covering about the middle section. And specifically, the IB wants you to know Fe2 plus and Fe3 plus. Well, here's a bonus for you. You have copper plus 1 charge and copper plus 2 charge. Whoa, hold up. Okay, so you geniuses out there might probably wondering why or how transition elements have such low charges. Well, for IB, they don't really want us to know, so we're not going to bother with it. Predict whether a compound of two elements would be ionic from the position of the elements in the periodic table or from their electronegativity values. Well, prior to that, I will head to the 8 valence electron store to see anything is there. Well, okay, there's fluorine right here, group 17 of course, and she's looking for a book. Well, oh, okay, well she already managed to find a book. Let's see. Wow, she really loves it. Let's check the cost. 8 valence electrons. Well, she had enough. Okay, well let's see how much she has. Okay, from my count she has 1, 2, 3, 4, 5, 6, 7 valence electrons. Well, that is not enough. She needs that 1 extra electrons for her book. Okay, well, the problem is, how will she get it? Oh, look, there's a running noble gas around here. And let's see how the bonding goes. The fluorine was trying to ask for the extra electrons, but let's see how much does the noble gas has. She apparently has 8, and she said no. Whoa. Hey, it's the noble gas again. Well, I guess she doesn't want the book. Despite from being the name noble gases, I guess they are quite selfish. And here's Francium looking for books, and he spot his, well, oh, what is this? An electron. And now he's just gonna have a -1 charge. And okay, well, he's just gonna put the book back and carrying that 1 electron around and moving on with his life. Oh, well, here's the fluorine. Well, I guess now, luckily, francium doesn't need the electron that he needs, and he's just gonna transfer the electrons to fluorine. So now fluorine is pretty much stable. Now, let's not trust any noble gases, shall we? Alright, let's move on to the real subject. 1.7. 1.7 will be the magic number, and here's why. My lovely classmate here will demonstrate that if the difference of electronegativity from 2 elements in a compound is greater than 1.7, it will be ionic. For example, francium with 0.7 En and fluorine with 4 En, the differences will be 3.3, and you can see the distance that they're stating is pretty far apart. Okay, let's try a different example. Let's try magnesium oxide. So my classmates are going to step in. Well, their electronegativity differences will be 2.1. Well, since we have a weaker ionic bond, let's try and go lower than that. Let's try carbon dioxide. How about that? So my classmates are going to move in really close because they're actually sharing it. They're covalent. State the formula of common polyatomic ions formed by nonmetals in periods 2 and 3. It's just plain stating, so just know them. Okay, first off we have carbonate, and its formula is CO3 -2 charge. Next we have phosphate, and its formula will be actually PO4 -3 charge. And next we will have nitrate, and its formula will be NO3 -1 charge. And next we will have hydrogen carbonate, and its formula will be HCO3 -1 charge. And next we have hydroxide. Hydroxide will be OH negative. And next we have sulfate, and sulfate will be SO4 -2 charge. And last we will have ammonium, not ammonia, That's a mistake. So it will be NH4 plus. Plus, that's important. Describe the lattice structure of ionic compounds. Meet our new guy friend, Stefan. Well, the negative ions and positive ions are attracted just like guys and girls by the electrostatic attraction in a distinctive pattern. Just like many ionic bonds coming together. Just imagine a group of friends. Well, if you add more energy and surpass their ionic bond one by one, then the ion would be free. And so the lattice structure will get smaller. And just like the previous one, if you add more energy, this ion will be also free. And the lattice structure is just getting smaller and smaller. And finally, if you add enough energy and surpassed it, well, the next ion is just going to be free. And until you are left with one, it's just going to be free. You guys might be wondering, what happened if they are free? Well, the IV stated that the freely ions will have different property, but we are limited to know what kind of property they will have, so we will not be in depth on this topic. Alright, the last bonus. Well, the lattice structure will have a high boiling point and melting point due to the strong ionic bond. By the end of the day, I would like to thank my lovely classmates, and we should establish a great bond.